Kubernetes Training by Vistasparks Solutions Master Kubernetes Kites, the industry-leading container orchestration platform with our comprehensive Kubernetes training program. Learn how to deploy, manage, scale, and secure containerized applications across on-premises and cloud environments. This hands-on training helps professionals and organizations gain expertise in container orchestration, microservices architecture, DevOps practices, cloud-native applications, and Kubernetes administration using real-world projects and industry best practices. Contact unmentioned WhatsApp number and email ID to know more about our services. Vistasparks Solutions offers comprehensive training solutions that cater to your specific needs. Our experienced trainers will help you master Kubernetes and take your skills to the next level. With flexible delivery options, you can choose the format that suits you best. Whether you're looking to enhance your existing skills or learn from scratch, we have a program tailored to meet your goals. We provide guidance throughout your entire training journey from containers to cloud-native mastery. Our programs are designed for real-world impact. The company has been working on developing a new product for several years. The development process was long and difficult, but the final result is worth it. The company has invested heavily in research and development, and the results are evident in their latest product. The product is highly advanced and features cutting-edge technology. It is designed to meet the specific needs of its target market, taking into account factors such as climate, geography, and cultural differences. The company has also made significant investments in infrastructure and personnel, which have enabled them to deliver high-quality products consistently. The product is now available for purchase by customers worldwide. Kubernetes is widely adopted by major cloud platforms such as Google Cloud, Amazon Web Services, and Microsoft Azure. This widespread adoption has led to its recognition as an industry standard. Many companies have started to use Kubernetes as their container orchestration tool, further solidifying its position as a standard. Its importance cannot be overstated, as it plays a central role in modern DevOps, microservices, and cloud-native development workflows. Furthermore, its use is essential for any organization looking to take advantage of the benefits of cloud computing. In short, Kubernetes is the go-to solution for container orchestration across all major cloud platforms. Vistasparks Solutions offers a range of services that cater to the needs of businesses and organizations. The company provides expert training and consulting services to help companies improve their operational efficiency and reduce costs. By leveraging our knowledge of cloud computing and containerization, we assist clients in optimizing their IT infrastructure and implementing effective change management strategies. Our team of experienced professionals has extensive expertise in areas such as DevOps, cloud security, and compliance. We also offer customized training programs tailored to meet the specific needs of each client. The training program is designed for individuals who are interested in pursuing a career in DevOps, cloud engineering, or software reliability engineering, SRE. The program focuses on teaching the essential skills required for each field, including containerization using Docker, orchestration using Kubernetes, and automation using Ansible. The curriculum is designed to be flexible and adaptable to meet the needs of students who may have varying levels of experience. Individual training offers numerous benefits tailored specifically to each learner's needs. A personalized learning path ensures that participants receive instruction aligned with their unique objectives and experience levels. This approach enables learners to focus on areas where they require improvement and accelerate their progress. Furthermore, hands-on labs provide opportunities for practical application, allowing learners to develop skills directly applicable to real-world situations. Real-world projects and exercises can be added to a participant's portfolio, enhancing their credibility and value as a professional. One-on-one mentorship provides dedicated support from experienced instructors, guiding learners throughout their journey. Additionally, certification support is available to aid in exam preparation and provide access to recognized learning resources. With these elements combined, individuals can achieve recognized Kubernetes certifications, solidifying their expertise in this critical technology. The training program is designed to equip participants with the skills necessary to manage a large-scale, distributed system like Kubernetes. The training covers topics such as cluster management, service discovery, and container orchestration. Participants will learn how to deploy, scale, and manage their applications using Kubernetes. They will also gain knowledge on how to troubleshoot issues and resolve problems efficiently. Furthermore, they will be taught how to implement security measures to protect their applications from potential threats. Our corporate training programs are designed to meet the unique needs of each organization. We offer a range of flexible delivery options that can be tailored to suit your team's location and preferences. This includes on-premise training sessions, which allow for face-to-face interaction with instructors and peers, as well as fully virtual options that cater to remote teams and individuals. Our training programs are delivered by experienced trainers who have extensive experience in the field. They use a variety of teaching methods, including group exercises and real-world scenarios, to engage learners and promote active learning. Kubernetes is a container orchestration system that automates the deployment, scaling, and management of containers as a single unit. It provides a common layer for deploying applications across different environments such as on-premises, clouds, and hybrid setups. The key components of Kubernetes include pods, services, persistent volumes, and networks. Understanding these components is crucial for effective use of the system. In addition, Kubernetes has a rich history dating back to 2014 when it was first released by Google, IBM, and Lyft. Its architecture is designed around the concept of a cluster where multiple nodes work together to provide high availability and scalability. By mastering Kubernetes, individuals can improve their efficiency and productivity in deploying and managing applications. Furthermore, knowledge of containerization using Docker is essential for understanding how containers interact with each other and with the environment. This knowledge will help learners develop a solid foundation for working with Kubernetes. Kubernetes architecture consists of two main components, the control plane and the worker nodes. The control plane is responsible for managing the cluster's infrastructure and ensuring that all nodes are running correctly. The control plane includes the API server, the controller manager, and the scheduler. These components work together to manage the cluster's resources and ensure that all nodes are functioning properly. The worker nodes, on the other hand, are responsible for executing tasks and providing resources to the cluster. They are typically managed by the control plane through the use of APS and other tools. The worker nodes include the Kubernetes pod, which is essentially a virtual machine that provides a logical container for applications and services. Pods are highly portable and can be easily moved between clusters or environments. Step 1. Setting up a local environment. To set up a local environment for testing, we can use Minikube. Minikube is an open-source tool that allows us to run a single-node Kubernetes cluster on our local machine. Step 2. Installing Minikube. We need to download and install Minikube from its official website. Once installed, we can verify its installation by running the command minikube status. Step 3. Configuring Minikube. After installing Minikube, we need to configure it to work with our local environment. This involves setting up the necessary networking and storage configuration. Step 4. Creating a Kubernetes cluster with Minikube configured. We can create a new Kubernetes cluster using the Minikube start command. This will spin up a single-node cluster on our local machine. Step 5. Managing clusters. In addition to creating clusters, we also need to manage them. This includes updating the cluster's configuration, scaling the number of nodes, and upgrading the cluster's software. Step 6. Using Kind. Alternatively, we can use Kind to create and manage Kubernetes clusters. Kind provides a more streamlined process for creating and managing clusters compared to Minikube. Step 7. Deploying applications. Once we have created a cluster, we can deploy applications to it using the kubectl apply command. This allows us to test and validate the functionality of our applications in a real-world scenario. Step 8. Scaling clusters. As our applications grow, we may need to scale our clusters to accommodate increased traffic and demand. We can do this by adding more nodes to the cluster using the Kubernetes scale command. Step 9. Monitoring clusters. Finally, we need to monitor our clusters to ensure they are running smoothly and efficiently. We can do this by using tools like Prometheus and Grafana to monitor key metrics such as CPU usage and memory allocation. Step 10. Best practices. To get the most out of our clusters, we should follow best practices for cluster management. This includes regularly backing up our data, monitoring our cluster's performance, and keeping our software up to date. Step 11. Cloud deployment. For larger scale deployments, we can use cloud providers like AWS or GCP to host our clusters. This allows us to take advantage of their scalability and reliability features. Step 12. Security considerations. When deploying clusters in the cloud, we need to consider security risks such as unauthorized access and data breaches. We can mitigate these risks by implementing measures such as network segmentation and encryption. Step 13. Networking configuration. We also need to configure our cluster's networking settings to ensure proper communication between nodes. This includes setting up the necessary IP addresses and port numbers. Step 14. Storage configuration. Additionally, we need to configure our cluster's storage settings to ensure proper data persistence. This includes setting up persistent volumes and storage classes. Step 15. Troubleshooting. If issues arise during cluster deployment or operation, we need to be able to troubleshoot them quickly and effectively. This involves using tools like Kubernetes and debugging techniques to identify and resolve problems. Step 16. Continuous integration. Finally, we can integrate our cluster into continuous integration pipelines to automate testing and validation of our applications. Step 17. Continuous deployment. By integrating our cluster into continuous deployment pipelines, we can automate the deployment of our applications to production environments. Step 18. Monitoring and logging. Monitoring and logging are critical components of cluster management. We need to implement mechanisms to collect and analyze logs, as well as monitor key metrics such as CPU usage and memory allocation. Step 19. Alerting and notification. We also need to implement alerting and notification systems to notify us when issues arise during cluster operation. This ensures that we can respond promptly to any problems that occur. Step 20. Automation. Automation is essential for efficient cluster management. We can achieve this by automating routine tasks such as backups, updates, and scaling. Step 21. Documentation. Documentation is crucial for ensuring that our knowledge and expertise are preserved over time. We should maintain detailed documentation of our cluster setup, configuration, and operations. Step 22. Knowledge sharing. Sharing knowledge and expertise with others is vital for advancing the state-of-the-art in cluster management. We should participate in online forums, attend conferences, and collaborate with peers to stay informed about the latest developments. Step 23. Community engagement. Engaging with the community is essential for staying informed about the latest trends and best practices in cluster management. We should participate in online communities, attend meetups, and contribute to open-source projects. Step 24. Research and development. Continuously researching and developing new technologies and techniques is essential for advancing the field of cluster management. We should stay up to date with the latest advancements in areas such as containerization, orchestration, and cloud computing. Step. Kubernetes provides several ways to deploy and manage stateful workloads, including deployments and stateful sits. These components allow you to control workload placement and automate batch tasks and scheduled stateful applications. By using Kubernetes native updates and rollbacks, you can ensure efficient management of your stateful applications. Additionally, scheduling and affinity rules enable you to place workloads on specific nodes based on their characteristics, such as CPU or memory resources. This allows for more efficient use of resources and better overall system performance. Furthermore, Kubernetes also supports the deployment and management of jobs and cron jobs, which can be used to automate batch tasks and scheduled applications. By leveraging these features, you can streamline your workflow and improve the efficiency of your systems. The key concept of networking in Kubernetes is that it is a complex system with many moving parts. This complexity can lead to issues such as network isolation, misconfigured networks, and other problems. To address these issues, Kubernetes provides several tools and features to simplify the process of setting up and managing networks. One of the primary goals of networking in Kubernetes is to provide a secure and isolated environment for each pod. This is achieved through the use of network policies, which allow administrators to define specific rules for how pods communicate with each other and external services. Network policies are implemented using a combination of CNI plugins and network policies themselves. The CNI plugin is responsible for creating and managing the network topology, while the network policy defines the specific rules for communication between pods and external services. In addition to network policies, Kubernetes also provides a feature called Ingress, which allows administrators to expose applications to both internal and external networks. This enables developers to access their applications from anywhere, whether they are on the same network or on a different network altogether. Kubernetes also supports multiple CNI plugins, including Flannel, Calico, and Weave. Each of these plugins has its own strengths and weaknesses, and administrators must choose the one that best suits their needs. Flannel is a popular choice among Kubernetes administrators because it provides a simple and easy-to-use interface for setting up networks. However, it may not be the best option for large-scale deployments due to its limited scalability. Calico is another popular CNI plugin that offers advanced features such as network segmentation and traffic prioritization. It is particularly well suited for large-scale deployments where high availability and scalability are essential. Weave is a lightweight CNI plugin that provides basic network functionality. While it may not offer all the features of more advanced plugins like Calico, it is still a reliable option for small-scale deployments. In summary, networking in Kubernetes is a complex system that requires careful planning and management. By using a combination of network policies, Ingress, and CNI plugins, administrators can create a secure and isolated environment for each pod. The choice of CNI plugin depends on the specific needs of the deployment, and administrators should carefully evaluate the strengths and weaknesses of each option before making a decision. Storage and persistence is a critical component of a Kubernetes cluster. In this module, learners will explore how to design and implement persistent volumes and storage classes to ensure reliable data persistence. They will learn about dynamic provisioning, stateful applications, and how to provision and manage persistent volumes and persistent volume claims. The key takeaways from this module include using dynamic provisioning to decouple storage from pods, designing reliable data persistence to decouple storage from pod lifecycle, and implementing cloud-native and on-prem storage strategies for databases and stateful workloads. By the end of this module, learners will have gained hands-on experience in designing and implementing persistent storage solutions for their Kubernetes clusters. This knowledge will enable them to create scalable and efficient storage systems that meet the needs of their applications. The Kubernetes cluster has been provisioned with a basic setup. The cluster has one master node and two worker nodes. There are three types of users: administrators, developers, and end users. Each user type has different levels of access to resources. Administrators have full access to all resources, while developers have limited access to certain resources, and end users have no access to most resources. This separation of access is achieved through role-based access control, RBAC. The cluster's security policy is based on the principle that secrets and sensitive data should be kept separate from application code and configuration files. To achieve this, The cluster uses secrets and config maps to store and manage sensitive information. These secrets and config maps are encrypted and stored securely. Pod security policy is used to enforce security contexts, policies, and hardening best practices across the entire cluster. This includes setting up network policies, security groups, and other security-related settings. By enforcing these security measures, the cluster can ensure that it meets the required standards for enterprise-level security. In addition to these security measures, the cluster also enforces pod security standards. This includes implementing security context constraints, which restricts the creation of pods that do not meet specific security requirements. This helps to prevent unauthorized access to sensitive data and applications. The cluster's security measures are enforced by a combination of automated tools and manual processes. Automated tools, such as the Kubernetes dashboard, provide real-time monitoring and alerts for potential security threats. Manual processes, such as regular security audits and vulnerability assessments, help to identify and address any security issues that may arise. Overall, the cluster's security measures are designed to provide a high level of protection against common security threats. By using a combination of automation and manual processes, the cluster can ensure that its security posture is always up to date and secure. Monitoring and logging are critical components of a Kubernetes cluster. In this module, we will explore how to implement monitoring and logging using Prometheus and Grafana. We will also cover health probes and centralized logging with Loki. The goal is to configure readiness and liveness probes to ensure self-healing and application health in real time. This enables zero-downtime deployments by aggregating and querying logs across dashboards to monitor cluster and pod health. By implementing these tools and techniques, learners can gain insights into their cluster's performance and identify areas for improvement. Jenkins provides a wide range of plugins that allow it to integrate with various other systems and tools, including Kubernetes, Docker, and GitLab. Jenkins supports both open-source and commercial versions of Kubernetes, as well as other containerization platforms like Docker. Jenkins also integrates with other popular DevOps tools such as Jenkinsfile, GitLab CI, and Circlesi. Jenkins supports multiple programming languages including Java, Python, and Ruby, making it easy to use for developers who are familiar with these languages. Jenkins has a large community of users and contributors, which means there are many resources available online for learning how to use the tool effectively. Jenkins offers a free version, as well as several paid options, depending on the level of support required. The Kubernetes cluster is managed by an administrator who is responsible for its maintenance and upkeep. The administrator must ensure that all components are running smoothly and efficiently. This includes monitoring the health of each component, identifying potential problems, and taking corrective action when necessary. The administrator must also perform routine maintenance tasks, such as updating software packages and checking for security vulnerabilities. Additionally, the administrator must ensure that the cluster is properly secured and configured for high availability. Cloud computing has been around for decades, but it's still not widely adopted due to its complexity and cost. Many organizations are hesitant to adopt cloud computing because they fear that it will disrupt their existing IT infrastructure. However, with the right tools and training, many organizations have successfully transitioned to cloud computing. The key to successful adoption is understanding the benefits and risks associated with cloud computing. Organizations must weigh the costs against the potential benefits, such as increased agility and flexibility, improved scalability, and enhanced security. They must also consider the potential risks, including data loss and cybersecurity threats. By carefully evaluating these factors, organizations can make informed decisions about whether to adopt cloud computing. The company has been providing training services since its inception in 2018. Since then, they have trained over 10,000 students across various locations. They offer a wide range of courses that cater to different needs and goals. Their courses are led by experienced instructors who provide hands-on training and real-world examples to illustrate key concepts. The company's mission is to empower individuals to achieve their full potential by equipping them with the necessary skills and knowledge. To achieve this goal, they have developed a unique approach to learning that combines theoretical foundations with practical applications. This approach allows learners to develop a deeper understanding of the subject matter and apply it in real-world scenarios. The company's commitment to excellence is evident in its rigorous testing and evaluation processes. All courses are carefully designed to meet the specific needs of each student, taking into account their prior knowledge and experience. By focusing on both theoretical and practical aspects, the company provides a well-rounded education that prepares learners for success in their chosen fields.